Alright, so we are looking at lesson 9 today. We're looking at torque. So hopefully after this lesson you'll understand torque. So we can discover some of the rules of forces that cause objects to rotate by using a light rod and a fulcrum. A fulcrum is just the name of a support about which a lever can rotate. So we can use almost any weights to balance the rod that we choose as long as we hang them the proper distance from the fulcrum. So I'm going to show you a very basic example of what a fulcrum may look like. And you may or may not have ever had one, but a seesaw on the playground, that is a basic example of a fulcrum. Now if you think about it, if you put your mom or your dad over here, and then you put a little 4-year-old you over here, what always happened? Your dad went down and you went up, right? So the way that you would make it move is your parent would have to just push off the ground, and then they would go up and you would briefly go down, and then gravity would pull them back down pretty quickly. So the way that y'all could make it so it would balance out, you would have to put on the fulcrum, your dad would have to be a lot closer here, and you would have to be all the way at the end. And physically, with using physics, we could figure out exactly where your bodies would need to go using your mass and the distance away from the fulcrum. And that's what we're going to be looking at. How can we make our fulcrums balance out? So we can use almost any weights that we want to balance the fulcrum. So here are 3 different combinations of weights and distances that work. So this is 4, and it has to be 40 away to balance with 8 and a 20 Newton force. This one is 2, and its distance is 2, and this is 80 Newton force. This one is 8 away, and it's a 20 Newton force. Or 8 and 20 versus 16 and 10. So do you see any pattern here? This distance, 8 and 20, if you multiply those two numbers together, you get 160. And it's always 160 because it's always 8 and 20 on the right side. On the left side, 4 times 40 is 160. 2 times 80 is 160. And 16 times 10 is 160. So you're just going to do your distance times your force to make them balance out. Okay, so we're going to be calling the product of our force and the movement arm, the length that it is away from the fulcrum, a torque or a moment. We're going to use the Greek letter tau to represent torque. It kind of looks like a T, torque. And we're going to call the perpendicular component of the distance from the point of rotation to the line of action of the force the moment arm. And we find by experiment that a lever will not rotate if the sum of the clockwise torques and the counterclockwise torques are equal. And so that's what we're going to be trying to do. Make the torques that are counterclockwise and clockwise, or ones that are pushing down or up. But the problem with down or up, if I'm pushing down here and I'm pushing down here, this one is actually going counterclockwise and this one is going clockwise. So you can't just say down or up. That's why we do the clockwise and counterclockwise. But you want them to balance out. Alright, so let's look at an example. We have forces of 8, 4, 6, and F applied to a weightless board that rests on a fulcrum. And they balance. We want to know what F would have to be. So we're going to start with the ones that are going clockwise. So clockwise is this direction. So 6 and F are both going clockwise. And so the distance that 6 is from the center is 5. So we're going to do 5 times 6. And the distance that the F is going from the center is 10, because it's from here all the way out to here. So 5 plus 5 is 10 times F. And those are going to have to equal the ones that are going counterclockwise, which are the 4 and the 8. So the 8 is 4 centimeters away, so 4 times 8, and then the 4 Newton force is a total of 10 away, So that's going to be 10 times 4. So those are going to be your forces, and they have to balance out because it says it's resting balance. So we're going to say 32 plus 40 equals 30 plus 10F. And if you subtract, you'll get 42 equals 10F. And so your F has to be 4.2. But if you look at all of our numbers, they're all 1 sig fig. So F would have to be 4 newtons. And that would be your answer for that question. So that's how you would deal with a fulcrum and a board. Those are the easier types of ones that you're going to deal with. The ones that are a little bit more difficult are these wrench problems. So hopefully you know to move a little nut, you have to turn it either left or right. You may have heard righty-tighty, lefty-loosey. Maybe not, but you either are going to be tightening it or loosening it. And so the one that you have for your homework is a little bit easier than this one, which is good so that we can practice the more difficult problem. So you may want to, when we get home this evening, go back over this example just so that you can practice it again. But we want to know what torque, what does the force produce. All right, so the first thing that you're going to want to do is to draw a triangle here. And you may not be able to see it very easily, but there's an arrow right here. It's going this direction. And so we're going to find the force that is in the y part and the force that is in the x part. And that's going to be using sine and cosine. So if you use your sine and cosine, you're going to have 12 cosine of 30 and 12 sine of 30. And so our x part is going to be 10.39, and our y part is going to be 6. Okay, so those are your two forces that you're going to have. The x component part, we're trying to turn it, and it is no distance away from the center because it's just on the actual line that we are applying the force. So for the x part, your torque is 10.39 times 0, which is just 0. So it doesn't cause any torque. It doesn't cause any movement. And then for the y part, the torque distance is 10 because it's 10 away from the center. And the force of it is 6. So 10 times 6 is 60. And then for torque, your units are distance times force, which is N. So we have Newton times distance, which was in centimeters. Now we need two significant figures because we had 2 on these. So we need to put a bar over that 60. So that would be your torque that you would produce there. Okay, so your homework is 1 through 20 tonight. So make sure that y'all do those so that we can go over any questions that you have tomorrow.